Hi, I'm Tim Fox, and I'm here to talk to you today about BigDL. And this is going to be a video 3 of a 4-part series in training in BigDL. Today, we're going to be talking about transfer learning for image classification in BigDL. Now, I hope you've already seen my earlier examples on how to install and run BigDL on using the Docker container as well as using the VM. And then also my examples on feed-forward neural networks in BigDL. Little about me. I'm a data engineering and data science practitioner and a partner and principal at Elephant Scale. At Elephant Scale, we do training in big data, AI, deep learning, and machine learning. And I'm an author of data science in Python on LinkedIn Learning and an open source contributor to projects such as BigDL. So now, actually, we're going to do a little bit more interesting example. And so in this case, we're going to be using a transfer learning from an ImageNet model, and we're going to be using that for image classification using BigDL. Now, you can refer to the URLs here for getting BigDL itself as well as the tutorials that we're going to do here. So one thing about this example is that it's a bit more involved both in terms of complexity as well as in terms of processing power required than earlier examples. So what I'm going to do actually is I'm going to go and get a Amazon EC2 instance that will have enough horsepower to complete what I'm trying to do. So let's just go ahead and do that. So I'm going to go ahead to AWS here, and I'm going to get a Ubuntu image. Let's get something that has enough horsepower to really do what I need to do. So we'll go and get a M4 2X large in this case. That's going to give us 8 vCPUs, 32 GB of RAM. So, not going to be huge, but hopefully you're going to have enough power that we're able to run this. Now, I could actually try to run with a cluster. However, in this case, I'm just going to try to run it still on a single node, just a bigger node than what I may have available on my desktop. I'll give myself 100 GB of storage and root. Now I'm going to get a security group here that is going to open up the normal ports, port 80, 8088, and most importantly port 22, so I can make sure I can log into that. Okay, and I'm going to give it a key pair that I have. Go ahead and launch that. Okay, so here's my public IP. Let's go ahead and log into our instance. Okay, so we need to install several things. Most importantly, we need to install Docker. So let's go ahead and do that. Okay, so now that we have Docker, we need to go ahead and run this. So now it's time to go and get our repository here. Okay, so let's go ahead and we'll log in. Okay, so now I should be able to go to and we'll run BigDL Docker. All right, so now we have BigDL running in our Docker container on our new AWS system, and we're all ready to proceed to running our example. Okay, so we have Docker currently running now. What we're going to do is we're going to run our example. Let us go to the correct directory here, and we'll go to scripts. Okay, so first what we need to do is we need to get the sample images. I'm going to refer you to the documentation here to get this on your own. However, I'm just going to go ahead and demonstrate that you are going to need to download that. And once you get that file as a zip file, you will go and put that in the sample images directory. Okay, so once you have the sample images downloaded, now it's time to go ahead and run our script. So let's go over what we're going to have. So this is going to be for transfer learning. So we have a script here called run transfer. So let's take a look at what we have. First, what we're going to do is we're going to go ahead and set our BigDL home here, which is in assert local BigDL. And we're going to, actually, I already have that here, so that's good. Then what I'm going to do is I'm going to check my other variables here. It looks good. Now, one thing that I did here is I'm going to get my driver memory to be 16 GB because that'll help run this in a reasonable period of time. And it's going to run our script inception transfer.py. Okay. All right, let's look at that then. We have our, we're going to run inception transfer.py. So let's see what we're going to do here. So we're going to be using this flowers data set here. So what the flowers data set here, let me just review that really quick. That's in the sample images. And so we've set up in here some flower photos. And you can see here that we have photos under 5 directories: daisy, dandelion, roses, sunflowers, and tulips. And so what we're going to do is that these are each going to be interpreted as labels. And then within each directory, we have a bunch of images. Okay, we've actually divided the same photos up into test, training, and validation. And so, as you can see here, if we go to test, we have quite a bit fewer images, just a couple there, and so under each one. Now, what we're going to do is we're going to go ahead and we're going to run the inception transfer learning. So, what does it mean to be transfer learning? Well, what we're going to do is we are going to use the ImageNet pre-trained model to start with. In order to do that, we have to have the ImageNet model already there. And so what we're going to actually do is we're going to go ahead and download the BVLC Google Net Cafe model and BVLC Google Net Prototext. Those are standard Google Cafe model that we're going to import into our model. So we're going to run that. Now, to get the URL for that, go ahead and refer to the script, because when you get that, that'll have the proper URL that you can get. Okay, so now that we have that, what we're going to do is we have a few helper functions here that are going to help us load these things. And what we're going to do here is we're going to define our layers here. Notice here that we have our spatial convolution layer with ReLU activation here, and we have a convolution layer 1 here, another convolutional layer here, another convolutional layer, a pooling layer, and this is for the convolutional model that we're doing here. Okay, now we're ultimately going to be instantiating that in this no-aux classifier here, and you can see here that we have more spatial convolutional layers, and then as we define that, we're going to add in some more layers here. So you can see the layers here. Okay, now we're not going to be starting our training from scratch by any means. What we're going to do first is we're going to load our data. We're going to instantiate our model that we just saw. There's 5 classes. No surprise there. Remember, there were 5 different kinds of flowers. And here is our pre-trained cafe model that we're going to start with, GoogleNet ImageNet. Okay, so what we're going to call is we're going to call load cafe, which is going to import that model into BigDL. Okay, so once we do that, we're then going to load our data here, and we're going to put it in the correct format. One thing we're going to do here, we're going to do a little bit of transformation. We're going to make all the images to have this size, 224, and so we're going to put in a transformer in order to crop the image there. Always a good idea to crop so we know we're getting to apples kind of images, or we should say in this case maybe roses to roses. What we're going to do here is we're just going to run through a few, the first 20 images to be exact, and we're going to try predicting that. Now, this is before training, so we're not likely to get too good of results, but we're just going to see what ImageNet gives us here. Then what we're going to do is we're going to initial transformation. What we're going to do here, though, is we're going to go ahead and train a model. So here is where we're going to start training. First of all, we're going to load in and get our training data, and we're going to apply the labels according to the names of the directory. In this case, that's going to be 1 through 5. Remember that BigDL likes to have labels that are numeric starting with 1. So then we're going to call optimize here, and what we're going to do is we're going to call optimize here on our data, and what we're going to do is we're going to pass in our training data. Okay, so once we have a trained model, that'll take a little while, then we're going to go and get our results. We're going to run our test data, to do the same transformers for our test, and then what we're going to do is we're going to get predictions. And at the end of the day, what we're going to see is we're going to see our results here, which we're going to see. So we should see an accuracy of about 80% is what I believe we were getting, which is not bad considering that we have 5 different classes. So let's go ahead and we will give that a try. So what I'm going to do is I'm going to go ahead and I'm going to run my I'm going to run the transfer script here. And what I'm going to also do is just to remove some clutter, I'm going to ignore all the info and just look at the results. Let me go ahead and get this started. And what I'm going to do is I'm going to pause the video and come back because it will take some time, probably about 30 minutes or so. We ran the final result here, and in this case it was about 70% accuracy. That's what we have, and we can look at the results there. So let's go ahead and review what we have then. We have our GoogleNet Cafe model that we loaded. We did a corpus here of flower photos, and we went and trained a model there of doing a classification of 5 classes there on the flowers photos. And then we trained a model and went ahead and ran training and then tests and got the accuracy numbers from that. We could then take this model and we can go ahead and apply it to do classification for any of our Spark data that we'd like to do based on image classification. That's all for this video, so I hope you enjoyed it and you're able to do image classification tasks. We will have another video in this series, and I look forward to joining you with that again. Thank you very much.